Yeah, so the files I am sending to you, this is how you will see them. Each of the parameters has two files. You see one named with the actual parameter, then one has means attached to it. So first you open, if let's say you want to see the analyzed results for ear diameter, you open it. So when you open the ear diameter like this is a typical ANOVA table, AOV table, analysis of variance table. So in the analysis of variance table, your design was actually a factorial design. So you had factor A and factor B. One of the factors had 3 levels and the other had 4 levels. So you did treatment combinations and you actually came out with taking your data. I will give you another file. When I send the raw data in Excel format to you, you will see how I've arranged your factors and the treatments there. Each of the treatments you used is a combination of the two factors. So I will give it to you so that you see that one too. So in simple and short, factorial analysis, you look at whether there was significant difference in individual factors. That's factor A and factor B. Then again, you look at the interaction of the two factors if there was a significant difference. So you move straight away to the p-values. The far right one here under the p, those are the p-values. So if this value in respect of the factor is less than 0.05, we say there was a statistically significant difference. It means that the differences you see in your data you took or your analyzed results uh, is as a result of your treatments you used. The differences was gingered by your treatment. But if this value is higher than 0.05, it means that the differences you see, by all means, there are differences in your treatment. Treatment 1 recorded probably a higher value than treatment 2. So we don't look at those differences to say there is a significant difference. It's after the analysis that when this value, this p-value, is higher than 0.05, we say there was no significant difference. When it is lower than 0.05, we say there was a significant difference. And you can actually add statistically significant difference for that. So looking at this, for ear diameter, all your factors was not significant because this one, which is factor A, is higher than the 0.05 figure that we are talking about. Factor B2 is higher than 0.05, and the interaction, the A and B2, is also higher than 0.05. Let me actually see your factors itself, the explanation of your factors, and see something. Yeah, this is actually the chapter 3 that you sent to me. Treatment. So we are doing away with this. So it means that your treatment 1 was a combination of D and 7. And down here you have explained that D is developmental stage. So developmental stage plus, it means that your factors, the factor A was the one which had 4 levels, which is the growth stages. So if you see factor A in the analyzed results, it means that factor A is actually standing for growth stages. This factor, growth stages. So it had developmental stage, it had grain filling, late, and I think you said control. So those are the factor A. It had 4 levels, and the factor B also had That is the drought length, which is 7, 13, and 19. So in this example, in the example that I'm showing you, in this one, growth stages was not significant. Um, what do we say? What again? Growth stages and what? Drought length. And drought length too was not significant. And the combination of growth stages and drought length was not also significant. That is that is in simple that way. So when it is not significant like this, there you see this file ear diameter, it is 2. I have the ear diameter itself that is showing you the p-values, the ANOVA table. Then the second one I said means. So that is where you will see the means. Actually, this file is very important when there was a significant difference in this one. So if there is no significant difference, the only important thing you will find here when you open this one is finding your your means. Is your means that you need because it was not significant. But let's get to at least one of them which was significant so that I'll show you what the another value that you need from that place too. Let's see ear length. Ear length. Let me see if it was significant. This one too, none was significant. So let's forget about it. Let's say, let me go to the vegetative parameters data. I think plant height is there. So let me say plant height. Plant height to okay, plant height, some was significant, factor A was significant. So the plant height, it's like it's a chronological data. You took it, as you said, 5 times. You didn't let me understand you said replications. Replication is different from what you mean by this. You took it 14 days. So the first one, you see the this ear diameter, it was only one ANOVA table. It was only one ANOVA table, which stands for the data that you took once. But actually for plant height, something like plant height, you will see each table, it is at about 5 or 6 tables. Each table represents a point or a specific day, the data you took. So if you take 14 days, I can't write the whole thing, 20, 20, 14 days after planting for plant height here. So if you see something like pH, I've indicated it in the data, the Excel sheet that I'll be sending to you. So pH means plant height. 14 means 14 days after planting. So you go to the next one, pH 28 days. You go to the next one, you see pH 42 days. You go to the next one, you see pH 56 days. Then pH 70, then 84. That is how you will see all the vegetative data you took, which had like which is having a chronological kind of data. That is it. So if you take the 84 days, the ANOVA table is this one. All this is for 81 days. Then all this is for 70 days. So specifically for the 14 days after planting, you could see that factor B was not significant though, but factor A was not significant, but factor B was significant because the p-value is lower than 0.05. So for this one, when you see something like that, that is where the means becomes very important because you will need the HSD value. I used HSD, Tukey's honestly significant difference, to separate your means because it's simply because your treatments were many. Your treatments were more than 6. So LSD is not the best. So I used HSD. So if you want the HSD value, you have to open the means, the file that is named means. So let's open the means to see the HS value because this was significant. So when you open the plant height means, that is where 14 days. So all this is 14 days. 14 days to here, there are different tables. There are 3 tables representing 14 days. This first table here is for factor A. You see factor A at the top. All this is for factor A. Now the second table is this one. All this here is also for factor B. So factor A, there was no significant difference. If you go there back, you will see that factor A was not significant. So here we are not concentrating on factor A. This table is for factor A. We are not concentrating on it. If you will concentrate on it, it's the means that you need. Only the means that you need. You don't need the HSD value. So if you consider the factor B, this is the second table, which is for factor B. It is written here. factor B, you will see the HSD value here. Critical value for comparison, that is the HSD value. So this is the value you will write for. You will record it in your chapter 4 in the table as HSD. That is it. So for the interactions too, I think it was significant too. Yes, that one too was significant. The interaction was significant at 14 days after planting for plant height. So that one too, the interaction table start from here and ends here. So that one too, the critical value for comparison. In other words, the HSD value is this one. So you will need that one too, plus the means here. When you finish with all these three tables, then you now come to another day, which is we are moving from 14 days to 28 days after planting. So it also have three tables. This is for factor A. This table is for factor A at 28 days after planting. This table is for factor B at 28 days after planting. And the interaction 2 is here. Is the next table for 28 days after planting. So always there is the critical value for comparison, which is the HSD value. So all the best. I think that is what I can say about this.